All right, question number 9. We want to find intervals on which the function is increasing and decreasing on 0 to pi. So we have f of x is equal to negative 2 times the cosine of x minus the square root of 3 times x. And this interval is from 0 to pi. Okay, so I'm thinking of the unit circle, and we are going from 0 to pi. So just this top half, this arc. All right, so we're going to find the derivative first. So the negative constant can come out front, negative 2. Derivative of cosine is a negative sign. And then we would do the derivative of the inside using chain rule, but the derivative of x is 1. So I'm going to leave that alone. And then the derivative of x, you're going to use the power rule. 1 times this coefficient will give me negative square root of 3. Subtract 1 from that coefficient, and that x goes away. All right, so when we simplify negative times a negative, we get a positive 2 sine of x minus the square root of 3. We're going to set this equal to 0. And then we're going to solve for x. So if I add square root of 3, we will get positive square root of 3 equals 2 sine of x. Divide by 2. And so we get square root of 3 over 2 equals sine of x. And from here you would do the inverse sign, but it's not easy to figure out those from the calculator. And so I'm going to just kind of point out the x values that give us a square root of 3. So on the unit circle, we have ordered pairs. 2 ordered pairs, or 2 values of pi, will give us square root of 3 over 2. Square root of 3 over 2 is the y coordinate. So we go over a half and then up more. So this ordered pair, let's say this is pi over 6. This is 2 pi over 6, which reduces to pi over 3. So pi over 3 is going to give us the ordered pair 1/2 comma square root of 3 over 2. X coordinate, y coordinate, sine is corresponding to the y coordinate. So this is 1 pi over 3. And then this next value, 2 pi over 3. Will also give us a square root of 3 over 2. So this is a negative 1/2. If you go to the unit circle, negative 1/2 square root of 3 over 2. Now, when I was saying you can continue to work this, you would have to do the inverse sign. Sine inverse of square root of 3 over 2. And you would do that to both sides to get x by itself. So x would equal, if you just kind of move that over. But it's not really easy to see that, and you also got to kind of follow the rules for the inverse sign, the restrictions to figure that out. But since we are restricted from 0 to pi, I'm just using the unit circle. So we have 2 values. Let's say that this is 0, this is pi. We have 2 values, pi over 3, and then 2 pi over 3. So we got 4 sections to test to see increasing and decreasing from 0 to pi over 3, pi over 3 to 2 pi over 3, and then 2 pi over 3 to pi. I'm going to test something in between each of these. So let's just test pi over 6. That's here. We'll test the middle value, which is pi over 2. And then over here, we can test, this will be 5 pi over 6. Okay, so these are the values I'm going to test to see what's happening. So I'm going to use this function. So if I do f prime of pi over 6, so I'm plugging in pi over 6 into sine. Pi over 6 is going to give me 1/2. That's the x coordinate. So we're going to get 2 times 1/2 minus square root of 3. All right. So 2 times 1/2, that's 1. Now, square root of 3 is going to be bigger than 1 because 1 times 1 is 1. And the square root of 3 is going to be a little bit bigger than 1. So I'll have 1 minus something bigger than 1 is going to give me a negative value. So this part right here is going to be negative. All right. The ordered pair for pi over 2, this one right here from the unit circle, pi over 2, the ordered pair, x is 0, y is 1. So when we do f of pi over 2, we will be plugging pi over 2 into the sign. When we do that, pi over 2 is going to just equal 1. So we get 2 times 1 minus square root of 3. Now 2 times 1 is 2, and square root of 3 is 1 point something if you do that in the calculator. 2 minus 1 and some change is still going to be positive. So this answer overall is going to be positive. Again, don't really care about the numerical value. We're just looking at the sign. So this middle section, we get a positive here. And then if I do 5 pi over 6, it's also going to give me 1/2 mirror image of that one. F of 5 pi over 6, going to give me 1/2, so it's going to be a repeat of this one. So it will be 2 times 1/2, which will give you 1, minus square root of 3. That still will give you a negative. So this section here is negative. So we have negative from 0 to pi over 3. And we also have negative from 2 pi over 3 to pi. And then we have a positive interval from pi over 3 to 2 pi over 3. So you can do the same thing with trig functions. Just got to remember, find the derivative, set it equal to 0, get the critical points, and then you just test what's happening in between. I'm sorry, I didn't realize all of that was kind of off the page, but just test in between each number. All right, so we are looking for increasing, never decreasing. This says decreasing, never increasing. We have both, so C. And we're looking increasing first. Increasing first. All right, so I'm going to do a fraction bar. And we want pi divided by 3 to, all right, so let's see if we can get this right. So we want 2 pi divided by 3. Why is that an extra space here? There we go. All right, so we got our increasing interval. Now we got our decreasing interval. We have 2 of them. Separate with a comma. Go ahead and add both of them here. So we are decreasing 0. I went over too much. 0. Lost my comma. 2. Divided by 3. And then here, we got 2 pi divided by 3 to pi. It keeps unclicking. Okay.